If you sit down to write a choose-your-own-adventure story, your timeline immediately fractures. Every single decision your reader makes creates a parallel universe that you have to track and resolve. As those narrative paths multiply, you are forced to juggle entirely different creative disciplines simultaneously. You have to dream up immersive environments, draft authentic dialogue for multiple characters, maintain distinct emotional arcs, and pace out the tension so the story never drags. The human brain hits a hard limit. Try to hold 50 intersecting plot lines in your short-term memory and continuity errors slip in. A character who died in Chapter 3 suddenly speaks in Chapter 4, or a crucial item disappears from the inventory entirely. Writing branching interactive fiction quickly becomes an exercise in database management. It requires the precision of a structural engineer to keep the variables aligned before you can even begin to be creative. To handle this massive cognitive load, writers often turn to standard, cloud-based AI tools. They paste their sprawling outlines into a single chat window and ask the machine to sort it out. This diagram shows exactly where that approach fails. Forcing a single language model to act as the world builder, the dialogue writer, and the structural editor all at once creates conflicting instructions. The model averages out your complex prompts and spits out safe, predictable prose. Relying on external corporate servers introduces a major security flaw. Every original plot point, character quirk, and world-building detail you paste into that prompt box leaves your local machine, becoming training data for a tech company's algorithms. Software developer Venkat Chavan Nagabhushana looked at this bottleneck and built an alternative. He designed a localized system that drops the single chat interface, replacing it with a virtual writer's room populated by distinct agents. To get specific, highly detailed output from a language model, you have to stop treating it like an all-knowing oracle and start treating it like a specialized production crew. Venkat's project is called the Interactive Fiction Co-author. It runs on a Python and Flask backend, wrapped in a responsive, cyberpunk-styled web interface. Instead of a single monolith, the platform routes your creative inputs to 4 dedicated AI personas. Each one follows a strict set of system prompts to handle exactly one aspect of the storytelling process. First is the plot twister. This agent is isolated from the descriptive writing and instructed strictly to inject suspense. It evaluates the current narrative path and actively looks for clever ways to disrupt the reader's expectations. The workload then splits again. The world builder focuses entirely on generating immersive, atmospheric environments, while the character developer operates separately to manage internal motivations and long-term emotional arcs. Finally, the dialogue specialist ignores the physical setting entirely. Its singular job is to craft natural conversations and ensure that individual speaking patterns stay consistent across the story. By isolating these variables, each module operates without conflicting instructions. The final text is woven together from highly concentrated, specialized outputs rather than watered-down averages. Separating these tasks creates a new mechanical hurdle: memory. When a reader makes a choice, how do 4 independent agents remember that specific decision 50 pages later? This diagram shows the back-end solution: graph-based state management. Instead of reading a flat text file, the system maps every choice into a network of connected data points. The system tags specific character inventories and world conditions inside these nodes. It maintains absolute continuity, ensuring that an agent operating on path B knows exactly what happened on path A. This state persistence prevents plot holes. It locks in the timeline of previous choices, giving the agents a rigid factual framework to reference before they generate their next paragraph. Without this underlying mathematical structure, the text generation would drift into nonsense. Graph-based management turns a collection of independent language models into a reliable, coherent story engine. All of this complex routing and memory management happens without a single ping to an external server. The platform severs the connection to the corporate cloud entirely. Venkat built the application to integrate directly with Ollama, a framework designed to run large language models locally, right from a standard hard drive. The system utilizes Microsoft's Phi-3 mini model, condensing 3.8 billion parameters into a highly optimized package, allowing these specialized agents to run smoothly on a personal computer with just 8 gigabytes of RAM. Because the processing happens locally, the security flaw of cloud computing vanishes. Every world you build, every character draft, and every branching storyline remains safely inside the physical casing of your own hardware. Protecting your intellectual property in modern creative software requires keeping the models on your own desk. Complete narrative control requires complete data ownership. Venkat's interactive fiction co-author is a working blueprint for how we will interact with language models going forward. The single omnipotent chat window is highly inefficient for complex tasks. We are moving away from passive prompt typing toward active management. The writer steps out of generating raw text and takes on the role of a director, managing an ecosystem of highly specialized workers. You no longer need an enterprise computing budget to build a complex software architecture. An everyday computer with standard memory can host an entire localized studio, working in tandem to produce intricate, sprawling narratives. The most effective creative tools being built today don't try to replace the author. They provide a dedicated, private team that collaborates with you to execute your exact vision.